Okay, so we're going to talk about ionic bonding to start out this next unit. So an ionic bond, start out with the definition of what an ionic bond is. All right, this is a positively charged ion, positively, is attracted to a negatively charged ion. And then, of course, the definition you've probably heard before, ionic bonds transfer electrons. Okay, whereas covalent bonds share electrons. Ionic bonds actually transfer electrons from one ion to the next. All right, just a couple more small things to keep in mind. These happen between metals and nonmetals. To have a metal ion from the left side of the periodic table and a non-metal from the right side of the periodic table. Okay. Also, just a monatomic ion consists of only one atom. All right, so like Cl minus, Na plus, Al3 plus, those are all one atom. Okay, mono meaning one, atomic meaning atom, put them together, monatomic. Next is polyatomic. All right, so poly meaning more than one, again, atomic meaning atom. So you have atoms that consist of more than one, or sorry, ions that consist of more than one atom. So you have like phosphate, you've got nitrate, phosphite. Okay, so those are some examples. So you have two atoms here, two different atoms. You have a phosphorus here, and you have an oxygen here. Okay, you have multiple oxygens. Actually, you have nitrogen here, you have multiple oxygens. All right. One without oxygen, cyanide, you have carbon, and you have nitrogen. Okay, so these are more than one. You're going to get a list of all the polyatomic ions you're going to be able to use. Okay, and you're going to need to learn how to use those properly. Okay, so if you were to look at, when we talk about transferring electrons, it's going to come back to the Lewis dot structure. So if we were to draw the Lewis dot structure for sodium, that's what it looks like. It has one valence electron, okay, and then chlorine in group 7, or in the 7th group there, so it has 7 valence electrons. Again, the idea is to get to 8, okay, either by getting rid of what you have or gaining more, okay. So in this case, sodium is going to lose its electron, okay. It's going to lose its electron and become Na plus, okay, because it lost one electron, so it's going to have an overall positive charge. Chlorine is seeking out an extra electron, so it is going to take that electron that's floating around and become Cl minus. Okay, nothing's happened yet except that we have made 2 ions. We've made a sodium ion and we have made a chlorine ion. Okay, now, like magnets, positives and negatives are attracted to one another, so they're going to come together and create ACl, which is neutral overall, because we have a 1 positive here and a 1 negative here, so they're going to balance each other out and give us a neutral compound. Okay, remember all compounds be neutral. Okay, all compounds must be neutral. So if yours is not neutral, if you don't have the same number of positives as you do negatives, then you're gonna struggle with making a correct compound. Okay. So let's go over one more thing, and then this video will be done. Okay, just as a reminder, this is your periodic table. Very short, very quick. 1, 2. There we go. Okay, if this is your periodic table, all right, and we're looking at charges. First thing we're really looking at in basic ionic compounds, we're only going to look at the simple charges. So everything in this first column, everything right here in this first column, remember, has one valence electron. Okay, so because it has one valence electron, it's going to get rid of that one valence electron and create a +1 charge. Okay, everything in this second column, this second group, has two valence electrons. Again, it is easier to get rid of 2 than it is to take on 6 to get to 8. Okay, remember the goal is to get to 8. Okay, so everything in this column has 2 valence electrons. It's going to be easier to get rid of 2 than take on 6. So it's going to get rid of those 2 and create a +2 charge. Everything in this column has 3 valence electrons. Again, it's easier to get rid of 3 than it is to gain 5. So it's going to create a +3 charge. Okay, everything here has 4, so it's going to create a plus or minus 4. Okay, not a whole lot is going to be asked of this this column right here. But then we get into the negatives. So this column has 5 valence electrons. Now you're getting into where you're closer to 8. So it's going to be easier to take on 3 than it is to get rid of 5. So it's going to take on those 3 and have an overall -3 charge. 6, 7, and 8 are going to be the same. So 6, you've got 6 valence electrons. It's going to be easier to take on 2, so it's going to have a -2 charge. Group 7 is going to take on 1, so it's going to have a -1 charge. And then remember, group 8, the noble gases, they do not react with anything because they already have 8. They already have a full valence electron shell. Okay, so if you can remember that group 1, everything in group 1 creates a +1 charge, group 2 creates +2 charge, group 3 creates +3 charge, so on and so forth, you're going to be just fine, okay, in remembering and making compounds, okay?